You ever just stop and wonder how your phone knows your face? Or how Netflix is so weirdly good at knowing exactly what movie you want to watch next? Well, I promise you, it's not magic. It's something way cooler. And today, we're going to unpack exactly how computers get to be so smart. I mean, really think about this for a second. Your email, every single day, just silently sifts through all this junk, protecting you from scams and ads. It's making these little judgments, these predictions, all on its own. Nobody is sitting there programming it to block that specific email. So, how does it learn? How does it know the difference?
Well, the answer is this incredible field called machine learning. And this definition, it absolutely nails it. See, it's not about writing a million lines of code for every single possibility. No way. It's about giving the computer a whole bunch of data and letting it figure out the rules for itself. It's about teaching it how to learn.
Now, just like people, computers can be taught in a few different ways. So let's think of them as three main flavors of learning, each with its own special recipe for getting smart.
Okay, so the two most common types really boil down to one big difference: the data you feed them. First up, we've got supervised learning. This is like studying for a test with the answer key right there. The data is labeled. We already know the right answers. And the whole goal is to predict a specific outcome. On the flip side, there's unsupervised learning. And you guessed it, it's the total opposite. We have unlabeled data, no answers, and we're just asking the machine, hey, can you find any interesting patterns or groups in here for us? And then we have our third flavor, reinforcement learning. Now, this one is really cool. It's where a machine learns pretty much the same way you or I do, through trial and error. Just imagine a character in a video game. When it makes a good move, it gets points, a reward. When it makes a bad move, it loses health, a punishment. Over and over, it learns the best way to win the game. And listen, this is not just for playing games. The power of this approach is absolutely staggering. Back in 2016, a program called AlphaGo, which was trained using reinforcement learning, did something that experts thought was decades away. It beat the world's best human player at Go, one of the most complex games ever invented. Just mind-blowing. So while all three are fascinating, for the rest of this explainer, we're going to zero in on the most common, most widely used type, supervised learning. This is that learning with a teacher method we talked about, the one that uses the answer key. Honestly, the best way to get your head around supervised learning is to think about teaching a kid with flashcards, right? You show them a picture of a cat, that's your data, and you say cat, that's your label. Then you show them a dog and say dog. You do this over and over. Pretty soon that kid can look at a brand new picture of a cat, one they've never seen before, and say, hey, that's a cat. The machine learns in almost the exact same way. So what does this labeled data actually look like to a computer? Well, usually it's just a big table, kind of like this classic example using flower data. Each row is a different flower. The columns with the measurements, like the petal length or sepal width, that's our data. And that last column, the one telling us the actual species of the flower, that's our label. That's the answer key. Okay, so let's just nail down some quick lingo, because you'll hear these words all the time. The inputs, the clues we give the machine, like those flower measurements, are called features. And the output, the thing we're trying to predict, in this case the flower species, that's our target variable. So features go in, and a prediction for the target comes out. Simple as that. And that really brings us to the core process, which is actually pretty straightforward. Step 1, we feed the machine a ton of our labeled data. Step 2, the machine, or the model as it's called, starts to train itself. It's looking for all the little patterns that connect the features to the target. And then step 3, the really fun part, we give it brand new, unseen data, and it uses everything it learned to predict the answer. Now, when we're using supervised learning, we're almost always trying to do one of two things. And the goal we pick really just depends on the kind of question we're trying to answer. So this breaks down into two main jobs. The first is called classification. This is what you use when your target is a category. The question you're asking is, which group does this belong to? Think spam or not spam, cat or dog. The second job is regression. You use this when your target is a continuous number. Here, the question is, how much or how many, like predicting the price of a house or how many sales you'll make next month. It all just comes down to whether you're predicting a specific group or a specific number. Okay, so this all sounds great in theory, but how do people actually do it? Well, for developers who use the Python programming language, there's one tool that is an absolute Must-have, game changer. It's a library called Scikit-learn. Scikit-learn is basically this huge, open source, meaning free, toolkit that puts all of these powerful machine learning algorithms right at your fingertips. It's built to be super efficient, but also really user-friendly, which is why it's become one of the most beloved tools in the entire data science world. And you gotta love its origin story. It actually started out as a student project back in 2007. But the open source community saw how brilliant it was, and throughout the 2010s, developers from all over the world jumped in to build it into the absolute powerhouse that it is today. It's a real industry standard. So why do developers love it so much? Well, for one, it's built on a rock-solid foundation of other amazing scientific libraries. It's packed with all the latest and greatest algorithms. But the real magic, the thing that makes it so special, is its focus on simplicity. It gives you one simple, unified way to work with all these different models, which makes the whole process of building and testing them so much easier, even if you're just starting out. All right, that was a lot of information, I know. So let's just take a breath and quickly run through the absolute key takeaways you should remember from all this. Okay, number one, machine learning at its heart is just about teaching computers to find patterns in data. Number two, supervised learning is the most common type, and it uses labeled data, data that has the answers included. Number three, with supervised learning, your goal is either classification, which is picking a category, or regression, which is predicting a number. And finally, number four, if you're going to do any of this in Python, Scikit-learn is the go-to tool. It's your best friend. So there you have it. You now get the basic idea that powers so much of the technology we use every single day. The same core concept that filters your spam could be used for, well, almost anything. And that kind of leads to a final question for you. Now that you know the basics, if you could teach a machine to do one everyday task for you, what would you have it do?